Hello, in this video I would like to demonstrate the function of the status signal and how it can be monitored. We prepared a board earlier and here you can see different steute products, but in this video we shall be concentrating on the RFIO with an inductive sensor as well as a 4-channel receiver to show both functions. Setting the status signal and monitoring the status signal. First, I shall explain how to set the status signal using the RFIO with an inductive sensor I prepared earlier. If we open the RFIO, we can see that there are different slots on its circuit board for a jumper. As you can see here, we have slots 1, 2, 3 and 4, and these are for the different status signal intervals of 10, 100, 1000 or 10,000 seconds. On delivery of the RFIO, the status signal is deactivated, as we can see from the jumper here, which is located in a neutral slot. We shall change that now in order to show you how the 10-second interval can be set. To do this, I improve the jumper and position it in slot number 1. Those are the first 2 pins. Once the jumper is in place, the RFIO, our transmitter in this example, is set to emit a status signal every 10 seconds. The status signal has the task of communicating the status of the transmitter to the receiver at a defined interval, in this case every 10 seconds. I would like to demonstrate this by actuating the switch. As you can see that the top here, the switch has already undergone teaching in on the receiver and is switched on. Normally, if I had not set a status signal to repeat every 10 seconds, then if there was a power cut in the production hall, the receiver would lose its power. Afterwards it would get its power back, but it would not know that the last status of the switch was on. It would then not engage the relay, in this case relay number 1 or channel 1. But because we have a status signal every 10 seconds, if the receiver is then switched off and back on again, the status signal would still be transmitted at the latest after 10 seconds. I should like to demonstrate this briefly by disconnecting the receiver from the power to simulate our example of a power cut in the production hall. Then the power goes back on, as I shall also simulate, and we can see that after just a few seconds the status signal is communicated. This means that the relay does not have to remain disengaged because the function status signal communicates the switching status to the receiver after 10 seconds. This part of the video showing how to set a status signal using an RFIO is now complete. In the second part of this video I would like to explain the second function, namely monitoring the status signals. We have set the status signal on the RFIO to communicate its status every 10 seconds. But I also have the possibility to select an operating mode on the receiver which allows us to query the status signal. This means that the signal is transmitted every 10 seconds and the receiver waits for it to arrive. If it does not receive a signal within the designated interval, it indicates this by lighting up a LED 4. This communicates to the user that, despite teaching in, one of the transmitters with its configured status signal is not working. In this way, it is possible to monitor and control steute wireless switches with status signals. I would now like to demonstrate this. First, we have to disconnect the receiver from the power and select the appropriate operating mode. I cut the power and reconnect it, selecting the desired operating mode, namely status signal monitoring. I select the operating mode by pressing the Learn button and keeping it pressed and then reintroducing the power. Once I have released the button, different flashing modes are activated, indicated by the LEDs MD and 1 flashing in turns. That was number 1, then 2, now comes 3, We can observe this by the different flashing patterns of the LEDs, that is number 4. We have to keep counting until number 9. That is 5, then 6, then 7, number 8, and finally number 9. We confirm with learn that we are in the desired operating mode, and immediately afterwards I select LED 1. This is because after we have selected the operating mode, the display asks which monitoring interval should be selected. Normally, after selecting the operating mode, the different LEDs 1 to 4 flash in turn and show the status signal monitoring intervals of 10, 100, 1000 and 10,000 seconds. Since we set our RFIO status signal to 10 seconds, we need a monitoring interval of 10 seconds corresponding to LED 1. The system is now configured on the receiver for a status signal from the RFIO every 10 seconds, with a status signal monitoring every 10 seconds. In total, this means that the receiver waits for a maximum of 22 seconds to see if the status signal is communicated. We can simulate that here by removing the battery from the receiver. The RFIO, the transmitter in our example, ceases to communicate a status signal to the receiver, which will take, as I mentioned, 22 seconds to be noticed. I remove the battery and the interval begins. 22 seconds while the receiver waits for a status signal, which in this case does not come. After 22 seconds, LED 4 lights up to indicate this, as you can see here. Because a status signal did not come from the RFIO, the receiver waited 22 seconds and then lit up LED 4 to indicate this in the operating mode status signal monitoring. If I now replace the battery and return power to the transmitter, the status signal is sent once more and the system is back where it should be. Once it is successfully reinstated, the system has a transmitter with a 10-second status signal and a receiver with status signal monitoring configured for 10 seconds, taking 22 seconds. This completes my demonstration of how to set a status signal using an RFIO and how to monitor a status signal using a 4-channel receiver.